So, hello again. I recently bought soluble filament. It means it can be dissolved in water, and I've been experimenting a little bit with it to get good overhangs, or in how should I say it, bridges or stuff. So I have this model here, and you can see that it's printed flat for convenience, and you need support here, and you also need support for the top. Now if you print it like this, I can use either tree support or normal support, which is illustrated here. You can see that I have separated the layers with the soluble. That's the beige color. So you have, this is how it starts. It looks pretty okay. Then you get an infill, and that I did for to have a lower print time, because I tried to print it as one solid piece. I will come back to that later, and it took over 12 hours for a whole set of these, of like 8 of these. Now I wanted to cut down on the print time, so I had to find out how I could do that. So you can see here by layer 6 comes up, and then it does an ironing, and then it prints the first layer of soluble filament for the supports, bottom support layer. There's 2 bottom support layers, 1 and 2, and then it prints with normal PLA, and then you can see it goes on to continue to make the supports for the new bridges that will come later. And then you can see you get to the second overhang, and then you get to it finishes that overhang, and you can see it's still using infill in the middle, like here. You can see it's still using infill, and then you come to the end of that one, and it closes the infill, and it irons the sides. And so far so good, but you have a different one. You come to the top one, and the global setting states that for strength I'm supposed to use 25% infill. The problem with this is that infill will go everywhere, and it will disregard anything that's considered a solid part of the object, which means that once it gets to the second overhang, it will not print the first layers correctly, because it sees that as supposed to have infill. So I'm going to show you that now. So we go back to the preview. So you can see here, you come up. This is still the middle section of the print, and you can see you go up to layer here. It's starting to get to the top now. See there, now it's creating the bridges over the supports to print the rest. And in this case I only used supports, and then you get here, and that is the first layer. But the thing is, when you print it like this, it does not look good, because you can see it's using infill way too soon. So it's barely making 2 layers. And let's say I have wall loops 3, quality, yeah, okay. So so the thing is, I want to see the whole infill is infill here everywhere. If you compare it to the start looks like this. So it's 1, 2, 3, and it starts on the 4 with infill. But if you print it like this, let's see here, 1, 2, 3, and actually starts on the 4. Still get the infill in the middle. So it would print correctly in this case where you only use solubles for support, but I am gonna show you what happens. So when I print it using this method, only using supports and soluble as an interface, what you get is a result that looks like this. So you can see here that this is the interface pattern, and you can see that it's kind of going gooey. There is a, I think there's an interface layer on top, but it's really checking the piece itself. No, there's that is actually what you're seeing here is the PLA itself, the first layer of the PLA. So I wanted to avoid this in order to have perfect prints. So I wanted to make perfect overhangs like this. I mean, see this one. This has comparison of overhangs how I want it to be. It doesn't look perfect, but it is a million times better, believe me. You can see it here as well. And in addition to that, I wanted to make like a slice in the middle, so it will be 2 overhangs. This is printed with 1 overhang. And the best way I could, there was another thing here. On these, when you print with supports, you get a distance from here in the intersection. You get a distance from where the support is to where the actual lines are. So there's always a distance from the support to the print itself, and sometimes there's like a visible gap, and I wanted to avoid that. So the way I countered this was with a model in Fusion 360 is I made these are like supports, physical support. It's actually part of the print itself, and it has been cut out by the part itself, so it's literally a perfect fit. And these overhangs and these physical supports will actually be printed in Soluble filament. So the supports will basically be towards this and not the print part itself. And what happens then is that you're actually printing with a soluble filament that prints as a part, making the surface iron and flat, and then the real part is printed on top of that, and then you just remove everything afterwards with water. So the supports come out really great. Now there are some problems with this. When you print with a 3D printer, you have to have a model piece with a certain amount of thickness, and in this case the thickness of this I came to was about 0.3 millimeters. And it doesn't sound like a lot, but when you're 3D printing, it actually is a lot. And it's a lot of filament that has to be dissolved, because like me, I'm printing with a layer height of 0.08, which means that this will be quite a few layers. And that is actually a good thing, because it means the part will be rigid and solid, and like supporting the rest of the part really well. Now, as I said before, if I do this, I also wanted to print this part more solid in the first, like so this whole bend here, this bottom part close to the support, I wanted to print that as a solid infill. I didn't want it to print with a 25 infill because I wanted that part to be strong against the other part that I have that is soluble. And the way I fixed this was that I actually cut it. So I have a body here. As you can see here, I made a body that compasses everything, and I just used it as a face. The face has really no depth. It's just a surface. And I used that with a modify split body function, where you can slice a body, and then I just removed the surface itself so it looks like it's part of the body, and then I exported everything as an STL file, because in Fusion 360 when you export everything that's visible, it will be exported. You don't really need to mark any bodies or anything. So in this case, also these small section parts that you can see here, let me see, I'll remove that, like this, this, and also on the other side. Split like this. All those parts are also separate pieces. Now I leave them as separate pieces when I export the STL file, because I'm going to show you why. When you go back to Orca Slicer, I'm just going to show you how you do it as well. So prepare, go back. So I'll remove that, and I'll actually leave it there just in case I need to rewatch it. So here, and then I import this, and this is the finished object. Let's see which side I'm supposed to put it on. So it's on this side. Just lay it flat. Okay. If you export it as an STL file, it's usually not a very good format, because you have not all the information maybe that you want, but if you use a step file, you cannot split it in the correct way. If you right click it and you select split, if you use a step file, you only have two objects, and what happens then is that it will scatter the objects all over the surface. Now I don't want that. I want the objects that are split to remain in their fixed positions, and that's what I use an STL file, because when I use an STL file I can select parts, and when I select parts, something happens. You can see here, this is the part I have selected. See here, now it's just one solid object, but since I exported it as multiple parts in the STL file, there's still information about that. So you can right click it, split two parts, and what you see happens here is that every single part you have is then separated when you print. An Orca Slicer, to a certain degree, lets you adjust the various values for each of these. So in this case I want to print the fixed plates here, and I want to change the filament. So here I can change the filament of that part. Actually that was the wrong part. Let's go back. I need to find this one, and that's the top part. That's the part there. Change filament, and I will have that as soluble, and I will also have this as soluble. Which one is that? Should be this one, and change that to soluble. Okay, so all here is now solubles. Now it will take from the global settings here. You know, I was standing in objects. When you're standing in objects, you can see each object. When you're standing in global, you can see the main settings, and the main setting here is that it should use 25% infill. Now I want to make sure that not everything is 25% infill, so I can click to objects up here, and since I split it to parts like I did before, you can go in and you can select every single part. Like I want this is the small piece there, I want that to be solid, I don't want it to use infill because it means it could be weak. So I will mark that one, and I will go to quality, strength, and then I can change the infill for that specific part to 100%. So before I do that, let's just slice it and we can see what happens in real time. Okay, so this is the part, and I'm just gonna change the angle a bit so you can see better. Now that part is actually kind of small, so I could just leave it at 25. But let's take let's take the bar here for instance. It's not. I'll just leave those at 25. But when we come up to here, you can see there is a problem. So this is the first layer of the top overhang, and you can see on this one that it's looking like it would end up in the same way. Now I don't want that, so what I can do is, remember I split that part to its own section, so I can go back and I can find that section in the slicer. Let's see if we can find it. I think it's one of the top ones, this one. So I can find that and I can right click it. No, I mean I can click it, and then I can go to strength and I can change the infill of that to 100% of that specific part of the part. There. So now I have forced that part to be 100%, and I can slice it again. Remember, it had like strings at first. And this is the same layer height as I had before. There. And then I just change that to 25 again. Remember, that's the first layer of the second overhang. This is how it should look like when you print it. Okay, sorry guys, I had to pause the recording. Had to get me some coffee and attend to my little girl. Now, where was I? Honestly don't remember. Let's just see if I can pick up on it. I think I was talking about the difference in infill. Yeah, so this is the, if you don't have, if you use this as a support, it will interpret that, because it will interpret it as still part of the main part, because it's not a support structure, it's a physical part I changed to filament as a support structure. So when it starts, these are actually the first layers, layer 1, 2 and 3, and then it starts making the infill of the supports, and that is what I want to avoid. I don't want it to start the infill on the first row of the actual part. I want it to start as a solid there, and the way you can go around this is, as I said, you split out so that, as you can see here in Fusion 360, let's see, bottom, So here you see I have split out this small section, and then I can adjust the infill of only this part, as I said. So instead of starting the print here, I can manually say that, okay, this part, when it starts on layer 100 when printing, instead of being part of layer 100 as the whole structure of the part, it will treat that cutout part as its own part with its own density. So I can go in and I can say 100% on that specific part, and when I then reslice it on that same level, on that same layer, you will still instead see that layer 101 will be solid, and the second layer will be solid, and the third layer will be solid, and the fourth layer will be solid, and the sixth layer will be solid. And then you can see it fills in the gaps. I didn't notice this before, but if you notice here, look at the walls. This is the first layer of the part. Notice here, the walls are increasing, the infill is not. And I think that is because it uses a different, like if you go to global here, you will see on quality, you see here, you have different thickness of the infill. Like it's printed the infill at 0.42 millimeters. And you have a lot of other settings. And so when I go to objects, you can see that it treats it as its own part, because you can see here, this is the first layer of it. Second layer, still just the wall. Third layer, still just the wall, because I'm printing the walls at 0.08 millimeters. And fourth layer, still the wall. Fifth layer, still the wall, and then it fills in with equivalent with 0.42. And then another wall, another wall, another wall, another wall, and then infill. Now it starts the first section of infill like I want it to be. So by doing this, I get perfect support structures, which I can remove as soluble, water-soluble filament. I get perfect walls, or near perfect walls, without the stringing problematic that you normally have in supports like these. This is actually how supports normally look like if you are just using them as normal supports. But instead of that, I end up with a support that looks pretty much like this. And so as you can see here, it looks a lot better. And the end result will also be a lot better. And there is almost no post-processing of it either. So it will print, and then it will treat. You see, by the time I get to here, I'm actually on the no longer on the sliced part. It will go up to here, because it will interpret that the top part of the sliced. It will basically, let me see, it will, when it's done with this part, which is solid, it will start with the rest but use infill, because it thinks it's part of the same part, even though it is not. And this part here is listed as only using 25% infill, which is why it automatically starts with 20% infill at that part. And then it continues until it gets to the top, and here you can see it starts to bridge over the infill, and then it starts to make the top, and then it irons. And so you end up having a really good printed part. And I think the only problem I experienced was that the first time I did this wall here, it became too thick. It was about twice that thickness, and it's really hard for the soluble solution to dissolve. And what I had to do is I had to remove the main parts of the filament, which was normal PLA, and then I had to just leave it in the bath for overnight, and then it was soft, and then I could basically just use a toothbrush to scrape off the soluble filaments that were left over. So I went in and I made it thinner. It's still kind of thick, I think, but I need a certain amount of thickness to have that support structure for the main part here when you print. So I just wanted to show you that it is possible to print parts with different infills and make it appear like the bridges and overhangs are printed perfectly. So you can print perfect and bridges and overhangs like this, but it's a little bit of a cheat. There is, how should I say it, the parts are limited by the layers. You couldn't make a section like in the middle here. You couldn't take a square out in the middle, and I honestly haven't tested that. I don't know if you can do that, because all my tests have been where the parts are on the side. I may try that for a different video, but I do know that adaptive layer heights don't work like that. But probably if you have a certain part, you could probably just cut out that part as its own part and select it in the list here as being either solid or non-solid. I don't know, I haven't tested that, but in my case it works well when the part is on a layer by layer basis, which is here. So I did try to use tree supports. You can see here I'm using normal supports. Don't think there are supports there. No, you don't have the ability to set. That would actually be fancy if Orca Slicer got the ability to set supports per object. That would make some funny things possible. But here under supports, if you instead use trees, that's gonna make for some. That was the main reason it took so long the first time. Here you can see I don't have so many support structures, but on the first one I had insane amounts of supports to make sure this top piece here was held in place. Even these are gonna take a long time. This is 2 hours just for a single piece. And if you change that to normal, it's not gonna be that long, pretty sure. I was 1:56 total time, 2 hours and 3 minutes. Let's see if I go to 3. Two hours and 31 minutes, so basically you say half an hour print time just per piece, because every time you have an extra piece of this, like I want to print 5 or 6, then it's that amount times X. So yeah, you saw the good one I printed here. This one, I printed about 8 or 9 of those at the same time, and they all came out perfectly fine, but it took like over 12 hours to print. That is a sacrifice you make if you want to print like this. It will take a long time, but your prints will look awesome, to say it like that. So if you have any questions about well, I will tell you what filament I used Let me see if I can find it. Give me a second. The filament I use is called Innovatefil PVA ULTRA, and this is the filament I use for the solubles. I think you can buy it anywhere else. It's not so expensive, but you don't need so much. This is in that spool that it comes with. It is compatible with the AMS, which makes this a lot easier. The AMS on the X1C carbon, and yeah, it's very hydroscopic. You need to dry it a lot. I think I printed this with about 13% moisture left in the chamber. It's pretty okay, I think. I haven't had any bubbles or problems with printing it. But yeah, if you buy that filament, don't do like me. I dry that at maximum heat in the what's it called? At the same time, I bought me one of those. I just need to check my order. Polymaker Poly Dryer. I bought one of these. It's actually really good. You just plug it in and leave it there. You can also print from it. I didn't do that. I put it in the AMS, but I put it on max heat for 4 hours. I don't recommend doing that. Maybe lowest heat for a lot of hours, because I felt it was almost making the filament stick together inside. It came apart pretty easily, but it felt like it was sticking together. So yeah. But anyway, I'm gonna end this video here. It has been over half an hour. Sorry for making it so long. This is probably just gonna be skipped through by most people, but I still hope you like it, and hope you subscribe and put a like on it, and see you in the next one. And for everyone subscribing to my channel, thank you from the bottom of my heart. It's fun to see that people like my stuff, and I also like to answer your comments. I have moderation on the comments, because you know, some people are not nice and I don't show those comments. Doesn't mean that I don't feedback on bad comments, but I don't like to let people drag me down to their level and beat me with their expertise of stupidity and maliciousness. Anyway, enough ranting. Thanks for watching, and see you in the next one.